Welcome to part 3 of Competency 2 quiz. In this video, we will work with operations involving vectors and complex numbers. Number 12. For vector mn, point M is located at 7, -2, and point N is located at 2, 10. Which one of the following statements is completely correct? Okay, so in order to find our vector, what we're doing is we're subtracting n, the elements of n minus m, okay? So this implies that we take 2. Remember, the x associates with the I. 2 minus 7, and that will all go in front of the I. And then we say add. Now, if it's going to be addition in the end after we're done, that's yet to be seen. So then now we do 10, which is your y value, minus the other y value. Well, that's a minus 2, and that associates with the j. Okay, when we clean this up, we have minus 5i plus 12j. So the only option that is going to satisfy this vector from m to n would be C. This is incorrect. This is incorrect. Now, well, D is kind of close. So we need to verify this magnitude of 13. So how do we do that? Well, we put that in our calculator. Now remember, when we put this in the calculator, we do a little manipulating and we turn it into a complex number. If you haven't worked with these, play with it, think it out. Why does that work? Okay. But for our video purposes, I'm not going to go through that. I'll just show you how to put in the calculator. So what we need to change that to, and I'm going to put in between stars because that's what we're doing. We're changing it. We're just leaving off the J. Okay. Leave off the J and see what happens. All right. So say math, arrow over to complex. We want number 5. Okay. Now we need to put in -5 second I and plus the 12. Push enter. And it's verified. 13 is that magnitude. So we're good with that. So let's go to 13. Which one of the following represents a pair of parallel vectors? Okay. By definition, parallel means that these items have the same slope. And to get the slope, we need the rise over the run, meaning we need a y value over the x. Okay. So we're literally going to put in the value in front of the j over the value in front of the I. That's the y over the j, how it's associated. Okay, so let's do that. All right, so let's say second y equals number 1. All right, so I have a -14 over a 4, and that's going to give a -7 over 2. Let's check the second vector value in A. Okay, so alpha y equals number 1, and we will put in -6, arrow down, 21, push enter. Oh, wait. Oop, I did it backwards. Oh, no. Okay, let me pull that down. Yeah, I put x over y instead of y over x. Not a good thing to do. So 21, go down. Notice how I grabbed it and then just did a type over? You can do that. And now we see it is 7 over 2. So A is a potential option. And for both of those, we have 7 over -7 over 2. Okay. Now let's keep that in mind because even though we think this is correct, we need to check the others. So for B, we know that the first vector has a slope of -7/2. So now we need to check the second one. But before we do that, I need you to notice something. There is no negative value in that second vector. The slope is positive then. There's no way this slope can be negative, but we'll do it anyway. Y equals number 1, and that's 28 arrow down 8, and it's not. It's a positive 7/2. So B cannot be a valid option. Now let's try C and D, but C, as you notice, these first two here, they're also going to be -7/2. So what we really need to test for C and D are the second vectors. Okay, so let's go alpha y equals number 1, and that will be, we're going to do C first, so that'll be 24 arrow down -9, and no, that is not valid. Okay, the second one isn't the same, so that won't work. So let's go ahead and put in that slope for the second vector of D. So that is alpha y, number 1, and we have 6 arrow down and -21. Obviously, it's not going to be valid because it's the reciprocal of what we're looking for. So the only valid option is A. All right, let's go to number 14. What is the measure of the angle between these two vectors? I plus 3j and 4I plus 3j. Okay, now what we're doing is we are subtracting. Now, I've already done this, so it doesn't matter which way you subtract. But I am going to, if we say this one is the first vector and we call this vector 2, I'm going to take 1 minus 2. Because I know if you do it the other way around, you'll get the correct angle, but it'll be negative. And remember, angle measures, it's a distance, and distance is an absolute value. Yeah, so if you get a negative, don't worry about it as long as the number is correct. Okay. But I'm going to do it to show you, that how it comes out correctly. So let's get it done. Okay. So let's go math. I'm going to arrow over. And before we begin, remember I'm changing this. So I'm going to say I plus 3. And this guy, I'm going to change it to a complex situation of 4I plus 3. Remember, we're doing this to manipulate in our calculator. Okay. All right. So let's do, wrong one. Math, arrow over. I need number 4 for angles. So I'm figuring out this angle. So I'm going to do 2 minus 1. That means I need 4, second I, plus 3, close my parentheses, push subtraction. Okay. Then math, arrow over, and I need number 4. Now I put in second I plus 3, close my parentheses, double check my entries that I'm taking the first vector angle minus the second vector angle, and I push enter. And there you go, we round it, and it will be option B. Okay, I recommend that you look at this further and compare and get it in your mind. What exactly is a complex number in the plane? And does that compare to what a vector is? There's a lot of similarities and a lot of the same things going on. So that's worth going back and reviewing again. And because of those similarities is why I can make my TIA 84 do what I needed to do, because it really doesn't differentiate between the two. Exactly. Okay. Now in the app, it does. Okay. But here it doesn't. Okay. Let's move on to the next item. What is the value of the projection I minus j on 2, negative 2i plus 3j? Okay, well, I'm going to use the application in our apps with our side tool to get the angles so we can add the angles together. So let's do that, okay? So let's do apps and arrow up until you see side tools. Press enter and enter again. We want number 4. So for our first vector, I already have it entered. So technically this is 1i minus 1j. So it's a positive 1x and a minus 1 for our y, okay? All right, now I already have that entered, but that's for vector 1. So let's go over to vector 2, and that'll be negative 2. So we need to change that. Oh, it's not giving us the next. I need to go next. There it is, there it is. Okay, so it's negative 2 and then plus 3 for our y. And to enter that in your calculator, if you didn't watch the other videos, you press the y equals. And notice that your r and your theta, they're gone now. And we can enter those again. So negative 2, remember to press enter. Then your 3, press enter. And then push graph where it says view. See where it says view right here? Graph below it. And then it gives you that r value and your theta. Theta is what we want right now. So what do we need? We need to take 120, let's round that to 24, and then a plus. Now let's go back previous. We push zoom. See where it says PREV. So push the zoom to go back. Now we need to add, let's make sure. Oh, one's not correct. I didn't push something right. Look, V1, that's not what we want. We want to push Y equals, and we need to be 1 and negative 1. I push something, something happened. So let's push graph view. There we go. That's the angle we need. Okay. Not sure what I did wrong there, but doesn't hurt to show you how to enter things anyway. Okay, so that says a negative 45. Take it at absolute value. Okay. So that means we need to add those two guys together to get the theta that we need to use. Okay. All right. So let's go second mode, exit. I'm not going to do this in my head. 124 plus 45. And remember, we were rounding. So that is roughly, remember all this is rounded. So that's roughly 169 degrees. Okay, so what are we doing here? We need to take one of our vectors. Well, let's go ahead and take this one, okay? And then we need our theta. Okay, so we are going to need to get our r. We need r cosine theta. All right, so let's go and get our r value. So that's math, arrow over, and that's our number 5. That's our magnitude, okay? So let's push 5. Now we need 1 I, so let's just say second I, okay? And then minus 1 because we knocked the j off, okay? All right, so let's push enter. Remember, when it gives you this, push x squared, enter. It's the square root of 2. That's what our r is. So r is going to equal the square root of 2. Always square it. Okay, now you could use it. You could copy that and use it. And we can do it both ways. In fact, let's do that right now. All right, so let's arrow up, grab that r, push cosine, and let's put in our rounded 169, close that, and push enter, and see what we get. Well, it's negative, but and lies our problem. None of these even if we try to get a fraction out of that, we're still going to have issues because of the squaring. Okay, but A and B are positive, so that knocks those two out. Now what do we need to do? Well, what we need to do is actually put C and D in the calculator and see if it comes out and matches what we have. I mean, it's best plan we have, so let's give it a try. So alpha y equals, and let's push enter. That's what we wanted. So -5, arrow down, square root of 2 as our denominator. Let's push enter and see what happens. No, not the same thing. Okay, well, let's try it with D. Alpha y equals, number 1. Okay, -5. And that magnitude of negative, that what that is a magnitude. It does jive. It works. You can go find that. It's a different magnitude of both, what it is the magnitude of both of those vectors together, and it is correct. Okay, so let's go down. That's another reason why I know this is going to work out. Okay, then second, okay, go down to our radical and pop in 13, and let's see what happens. That's what we had. Oh, it's very close to what we had. So if we didn't round quite the same, I bet we'd get the same thing. Okay, well, let's go back to our app and change our rounding. And I'm saying D is correct. And C, well, C wasn't even close enough. Think about it. A and B were positive. Well, that's not going to work. We had negative situations. Okay. And then we had the square root. We have the square root of 2 as r, but I think that was kind of like trying to trick us to get us to try the wrong thing. Okay, so let's give this a try. Let's go back to your app. Okay, arrow up. Let's look at what those angles really were. Okay, number 4, and it's still in there. So we had 45. That we didn't round because we didn't need to. But now let's go over to V2, second vector. We rounded to 124 point. Well, let's change that and then put that in. 123.67. 123.6. Oh no, 69. Sorry. 69. Let's try that. Okay. All right. So then we can add those together, or we could just put it in as we see it. So let's try that. Okay. All right. So let's go second mode. Let's back out of this exit. All right. So second square root 2. I'm going to arrow over. I'm going to say cosine. Remember, when we did this the first time, this up here with the 1.4141, see where my cursor is? Remember, that was where we took the square root of 2 and got the value, and that was a rounded value. Okay, so we're going to use the exact value, square root of 2. Now, cosine. Well, let's do this. Cosine theta, that's 123.69 plus the 45. Close parentheses. I'm just going to do it all together and see what happens. Okay, now let's push enter. That is very close. I mean, it is just essentially, if you look at these ending values here, it's a hair off. So D has to be the right value. Now remember, there was other formulas that you could use. You could have used the dot product over the magnitude. I chose to use R times cosine theta. There's more than one way to do this. This just, for me, was a better way. Now, the value of D, they used a different formula, and that's how they got -5 over the square root of 13. Okay. So let me show you something real quick. Okay, this is worth doing. Okay. So at least show you what that -5 is. Go up to your side tools, push enter, enter, go back to your number 4. Now, you see that we have V1 entered. Go to next, you have V2. So I'm going to use my math option again. We did this in other videos. Okay, so I have V1 up and I'm going to say graph. Now I'm going to take the dot product of these. Well, that'd be zoom. So I'm going to push zoom. But now notice here it has V1 times V1. Well, you've got to tell it V2. So push trace or next. Now we have V1 dot product of V2. Okay. So you push graph pick again. So push graph. See what you get right up here? Magnitude of -5. So there again, that is the part of uh, the other formula that you use. Okay, so it tells me that the formula I used did get the correct item because I was on the right track. Either way, doesn't matter. If you're using the study guide, you can go back and do this all by hand. I'm not going to because I have a quicker way of doing it in the calculator using our cosine theta. Okay? All right. So let's go to number 16. Which one of the following represents a unit vector in the direction of 10I minus j? Okay. Now this formula is the given, that's AI plus, BJ. Now that is the given. Whatever they give you to work with, okay, that's going to be your numerator. Oh, goodness, that decided to do its own thing. And that is not what I wanted. Okay, I wanted to show you it was a given. Okay, then what you need is that magnitude again, all right? So you need the magnitude of your A, vector A to the B, okay? And that's using the given. Okay, so first off, if you don't see in the numerator 10I minus j, mark it out. So that gets rid of A and C. So those are good. So now what we need to do is put in our given in to our absolute to get our magnitude. Now listen, remember, what do? I adjust them. So in the calculator, we are dropping the I off. I'm sorry, not the I, but the J. We're dropping off the J. So I need I minus the 1 into the calculator. Okay, so let's back out of this. Back out, back out. I just keep saying second mode until I get to my exit. Okay, let's find our math and arrow over to our complex. And we need number 5. And there it is. Okay, so now I have 10 second I minus 1. Minus the 1. Press enter. Okay, now remember, these are under the square root. And this value is the result of that. So how do I deal with that? I just push square. So don't push anything, and you can just push square. See where it says answer is squared, push enter. And that's what should be under the square root. And that gives me D, and B is not an option. Okay? Now, yes, when I do some of these things in the calculator, I am adjusting and I already understand where these elements are coming from. If you don't, please look at your study guides online. There's great videos out there. You really need to go and study further and learn where these things are coming from, why I can do what I'm doing on the calculator. Why does it work? I'm showing you, I already know it works, and you can play around and figure out, for yourself. Okay. All right. This is the last question for our competency 2, as far as the quiz questions. Thank you guys for watching and subscribing and liking and sharing us. Happy testing, everybody.